Let set A be x, y, and z and b be 1 and 2. Find the number of relations from A to B. I'll explain how to get the answer first and then the logic. So what they're asking us to do is, we have set A and B. So we have set A and set B. Right? So there are 1, 2 and 3 elements over here and 2 elements over here. The question is, how many types of relations we can establish between A and B is the question. Okay. The fundamental principle with which this works is, principle that we have to use is, can you guess what? Power set. Okay. So if you guys want to recall power set, I have it over there, over here. So power set includes all the possible subsets of a given set. So the set which we are talking about is what? Yes. So step 1 for such question would be, find the number of elements in the Cartesian product of A and B. So that is equal to number of elements in A and the number of elements in B. So here this would be equal to 3 into 2, that is 6. And then you have step 2. So this would be what? This would be finding the possible numbers of relation from A to B to be equal to 2 to the power of 6. Okay, so this is the whole funda. Understood? So basically there are 2, 4, 8, 16, 32, 64. 64 possibilities. This is how you figure out the answer. Step 1, find the number of elements in a Cartesian product between the given sets. Step 2, use this formula and you're done. Right? This formula comes from your, sorry, not that, not this, this. Right? And now on to explaining the logic behind this. Okay. So I already have typed in your set A and set B values, elements, that is x, y, and z, and here we have 1 and 2. So when I do run it, so I have the following output. Let me kind of take it over. The set A is made up of x, y, and z. Set B is made up of 1 and 2. The Cartesian product between A and B is z1, z2, y1, y2, x1, x2. Right? The number of elements in the power set is 64. That is 2 to the power of 6. So what is this funda? What is that we are talking about? See, I'll explain this. I can have a relationship. I can define a relation, right? And this relation will result in none of the elements being related to none of the elements. And so we have the following output, right? Null set. Or I can just relate z to 1. Okay, like over here. Or I can relate z to 2, like over here. Or I can relate y to 1, y to 2, so on and so forth. So my relation definition can relate only one pair, can have only one pair. Or I can have a relation defined in such a way that there are 2 pairs. There are 2 possible outputs. Right? So 2. I can also define relations such that I have 3 possible outputs. Of course, I have to go scroll a lot of, right, long way to figure that out, find that out. Still not here. Yeah, we have it over here. That's your first relation with 3 possible outputs. Okay, relationship, the 3 possible order pair, right? So the funda is, we can define in 2 to the power of 6 ways. I hope you guys understood the question. because the question itself is not that clear, right? It's kind of confusing. So stepwise, it's not too much. Just find the Cartesian product, number of elements in that, and then put that in the power of 2, and you have the answer. But what is the funda behind this? What is the idea behind this? What they're asking is, how all can I define the relationship between A and B, right? So that we have all the possible outputs, like what in all ways can I define, so that we have null set, then only one pair, then two pair, then three pair, so on and so forth. So apparently there are 2 to the power of 6 ways.